Hello students, in the series of video lectures, today we are going to cover the topic disk scheduling. Basically, disk scheduling algorithm is used by the operating system to manage the hardwares efficiently. And disk scheduling is done by operating system to schedule I/O request arriving for the disk. Disk scheduling is also known as I/O scheduling. Basically, disk scheduling is important because of 2 3 points. Like what will happen, like in the CPU scheduling, CPU have a single process, then process will X fully enjoy the CPU. He has never wait. In case of multiple processes, CPU switches among the processes. Then processes has to wait also. Same way in the case of disk scheduling, multiple I/O requests may arrive by different processes and only one request can be served at a time by the disk controller. If disk controller is free, then service will be served immediately. Otherwise, he has to wait. Thus, other I/O requests need to wait in the waiting queue and needs to be scheduled. Now, when IO requests are waiting in the wait queue, then there must be some policy to serve the next waiting IO request. That's why here we will use some kind of scheduling algorithms that will apply on the IO request. On the basis of that, operating system will decide that which IO request now I have to serve next. Two or more requests may be far from each other, so can result in greater disk arm movement. For example, I'm telling you with some example, like suppose this is our disk and this is disk arm. Suppose these are the track and these are the vectors and something like that. I'm taking just an example, so it's not accurate figure. Suppose head is currently reading the data from this location. Now, what will happen if he has to next service the request at this location? Then he has to move a lesser distance, or we can say he will read the data in lesser time rather than reading the data from here. And as we know, hard drives are one of the slowest part of the computer system. Thus, there's some kind of algorithm, yeah, there's some kind of scheduling so that they can be accessed in efficient manner. So for this kind of scenario, there are many disk scheduling algorithms, but before discussing the disk scheduling algorithms, uh, we should consider two, two or three technical points that are going to use in the algorithms, like seek time. Basically, seek time is the time taken to locate the disk arm to a specified track where the data is to be read or write. Uh, Indirectly, I have already mentioned time taken by a disk arm to a specific track. For example, like For example, like in case of this example, suppose the data is here and we have to next access the data from there. Then the time taken for the disk R to move from this location to this location will be called as the seek time. Okay, so basically, as we can see, as according to the definition, seek time is the time taken to locate the disk arm to a specified drive where the data is to be read or write. So the disk scheduling algorithm that gives minimum average seek time will be better. जाहिर सी बात है जिस एल्गोरिथम में हेड का मूवमेंट मिनिमम होगा that will be our best algorithm. Like in case of CPU scheduling, जिस एल्गोरिथम में वेटिंग टाइम मिनिमम होता था वो हमारा बेस्ट एल्गोरिथम होता है. Similarly, in case of disk scheduling algorithm, the algorithm that have minimum average seek time, that will be the best algorithm. Okay, so as far as next point, rotational latency is concerned, rotational latency is the time taken by the desired sector of disk to rotate into a position so that it can access the read-write head. Got it? So again, we can say the disk scheduling algorithm that gives minimum rotational latency, that will be better. Clearly, we can say. Now the next point is transfer time. Basically, transfer time is the time to transfer the data. It depends on the rotating speed of the disk arm and the number of bytes to be transferred. So indirectly from these three definitions, we can see disk access time is seek time plus rotational latency plus transfer time. As you can see, disk access time is the seek time plus rotational latency plus transfer time. Similarly, there is one more technical point is disk response time. Basically, response time is the average of time spent by a request waiting to perform its IO operation. Average response time is the response time of all requests. Variance response time is measure of how individual requests are serviced with respect to average response time. So again, we can say indirectly the disk scheduling algorithm that gives minimum variance response time, that will be better. And disk response time basically is the disk access time plus queuing delay, disk queuing delay. So these are the 2-3 common points that will be used in almost all the scheduling algorithms. So now we just come to the disk scheduling algorithm. There are number of scheduling algorithms. Like first one is FCFS. In case of FCFS, students, very sorry for some technical issues. Uh, okay, now let's continue. Our first algorithm is disk scheduling algorithm, and sorry, our first algorithm is FCFS, disk scheduling algorithm, like first come first serve. And as far as the FCFS is concerned, is the simplest of all the disk scheduling algorithms. And what will happen in FCFS, as you know, anyway, let's continue. Uh, so as we know, in FCFS, requests will be served as the order of arrival. So we all know from very starting of the operating system first lecture, FCFS is best algorithm in terms of fair chance, because when we are using FCFS, every request will get a fair chance. No indefinite postponement. Means we can say there will be no case of starvation. There are some kind of drawbacks also, like if we are strictly follow in some orders, then there must be some increment of seek time. Does not try to optimize the seek time, may not provide the best possible services. Like just discuss one example for that. Suppose we have number of pending requests are 23, 89, 132, 42, and 187. And before starting this example, I will give you some idea about this question. Suppose in UPTU exam, what they will ask, they will. So let's let's continue. So as far as this question is concerned, there are these three pending requests, and currently there are total 200 cylinders from 0 to 199, and the current head position is 100. So basically इन क्वेश्चन को सॉल्व करने में हमें करना क्या होता है, जो भी पेंडिंग रिक्वेस्ट दे रखी हैं इन सारी पेंडिंग्स को इन सारी पेंडिंग रिक्वेस्ट को डायग्राम इस लाइन पे ड्रॉ कर लो. लाइक हियर विल बी 23, 48, here is 89, then 132 and 187, and the lower and the upper boundary, that is 0 and 199. Now will be complete now. Thank you guys. Let's discuss this numerical in the next video. Thank you.